Okay, these notes are for Tuesday, November the 2nd. Today we're learning how to use the slope formula to find the slope of a line. And so the slope formula is a little bit challenging for students, so I'm actually going to show two different ways to find the slope, actually several different ways on different problems. But the slope formula is right here. It's a great formula to use when looking for slope. So I'm going to demonstrate how to use it, but again, I'm also going to refer to other methods that might be good for students. So the slope is a constant rate of change. We've looked at that before. We know that slope is rise over run. So if you're looking at a picture and counting the rise over run, like for example, this picture right here, the rise would be up 2. If I travel from this dot up to this point, I would go up 2 spaces. The run would be +1 because I'm going over 1 space to the right, so the slope would be 2 over 1. And we've used rise over run for several days now to calculate the slope of a line. But now if I give you different information, perhaps if I give you an equation or if I give you two ordered pairs, you can use the slope formula to come up with the slope of the line. Now the slope formula is the same thing as rise over run. When you do the rise, you're finding the change in the y values. How many steps am I going up or how many steps am I going down? That's the change in y. Change in this case means subtraction, and so when you do y2 minus y1, which is what the formula demonstrates, basically you're just taking this ordered pair and this ordered pair and you're finding the change in their y values. How much did it advance up or down, hence the rise. Likewise, the run, x2 minus x1, is just taking these values from here to here and seeing how much the x value changed, because the x value is like the x-axis, it runs left and right, and so you would use that part to find the change in x. Change again means subtraction. So for some students the formula is pretty intimidating, so let me go through the notes and we'll see which you can decide which method you prefer. So we're going to use the slope formula for this case because we don't have a picture this time. Now I could sketch a picture with these two ordered pairs on it and count the rise over run, but because I don't have a picture, I'm going to look at the slope formula and see if I can come up with what the slope for the line is. So the slope formula is y2 minus y1. Basically you take the two y values right here and subtract them to find the change in the y's. The bottom part is x2 minus x1, which is taking the x values here and subtracting them to come up with a change in the x. So right here in this line, it's demonstrated that the 4, -2, that's the first ordered pair, that is our x1 and our y1 value. The -1, 2 is our x2 and y2 value. So if I plug the correct numbers into the formula, y2 is right here, so I put a 2 and then a subtract. y1 is right here, so I put a -2. x2 on the bottom would be -1, and then I put a subtract. There's a subtract sign in the formula. And then x1 is right here. So basically plugging in the numbers, that's what I would have. Well, I know when I have minus a negative, I can always change that to plus a positive. So I'll end up with +4 on top. Down here on bottom, I might do the same thing again as far as my negatives and my subtraction goes. So -1 plus -4 would give me -5. And this is my slope. 4 over -5. Now we've looked at this in a table also, so I'm just going to quickly demonstrate the table method for this. If I took these two ordered pairs, 4, -2, -1, 2, and plugged them into the table, how much is it changing here? Well, it's going up 4. And then what's the change over here? It's going down 5. Remember our rate of change, or our slope in this case, is the change in y over change in x, would still give us 4 over -5. So we're getting the same thing. Again, so there's kind of two different methods that you can use. Let's look at an example here. We've got the slope is -2, or excuse me, the point is -2, -2, and 7, -2, and we're going to use the slope formula to come up with the slope. So I'm going to label my points to make it a little easier. This is x1, y1. This is x2, y2. So if I plug the numbers into my formula correctly, let me rewrite my formula just so I've got it there to see. y2 minus y1 over x2 minus x1. So I would have -2, which is this value right here, subtract -2, which is this value right here, y2 minus y1, over x2 is this value right here, which is 7, subtract x1, which is negative 2. Again, I'll fix my subtract negatives. On top, I'm going to have 0. On the bottom, I'll have 9. 0 divided by 9 is 0, so I have a 0 slope for this line. You could see this in a mini table. This is the last example I'll actually show the little mini table on, but you're welcome to use this process for any of the problems you want to do. If I have negative 2, and I have 7, negative 2, my rate of change here is 0. My rate of change there is up 9. 0 over 9 still gives us 0 slope. Now don't let the fractions intimidate you. If they're decimal friendly, just change them into decimals, put them in the slope formula, and solve and find the slope. So I'm going to label my points again, x1, y1, x2, y2, plugging into the slope formula. Now I'm going to convert to decimals real quick. This is 0.4, this one's 0.25, this one's 1.4, this one's 0.75. Don't have to do that. You can leave them fractions, but because all of these are nice, friendly decimals, it might be easier to see it in the problem. So I'm going to take 0.4, and I'm going to subtract from that 1.4. Then I'm going to take 0.25 and subtract from that 0.75. Well, when I do my subtraction, I get negative 1 on top. I get negative 0.5 on bottom. Negative 0.5 goes into negative 1 2 times, so my slope is 2. These are just repetitious, so I'm going to skip these examples. I will tell you there was a typo on this. This should actually be point -3, -5. This should be point 2, -2. So in working through it, you would want to reflect those 2 points. I'm going to skip this example because it's very similar to the 2 we did on the other side. Looking at a table, if I choose any 2 ordered pairs I want, I'll just choose the top 2. 4, -5 is one of my ordered pairs. 8, -3 is the next ordered pair. Again, I've got my slope formula, y2 minus y1 over x2 minus x1. If I substitute in 4, -5 for the x1, y1, if I substitute 8, -3 for the x2 and y2, I'm going to end up with -5, subtract -3, over 4, subtract, I think I wrote that backwards. Let me try that again. Sorry about that. If I have, let's see, -3, subtract -5, I wrote it wrong. And then 8, subtract 4, I'll fix my minus a negative there, which will give me 2 over 4, and that reduces to 1/2. Look at the table though. What's the change that's happening here? It's going up 2. And the change that's happening here? It's going up 4. 2 over 4 reduces to 1/2. I find that sometimes students, especially freshmen, struggle a little bit with the slope formula. I'm not saying we shouldn't use the slope formula, but if you can draw a mini table and come up with the answer and you feel like you're doing a better job at it that way, it's easier for you, then I encourage them to do that. Likewise on the problem before I skipped, let me run through this real quick counting the slope. If I go up 2, up 3 right here, that's +3, that's my rise, over 1, 2, 3, 4, 5, that's my run. My slope for this problem is 3 over 5. So there's different methods for different problems that you can use. This is an application problem. Basically, when you have worded scenarios, you can still find the rate of change. You need to know what different things represent. So I'm going to plug in my numbers real quick. I've got x1, y1, x2, y2. So I'll have 2,000 minus, oh, I wrote too big, sorry, 3,000 over 60 minus 20. Well, 1,000 or 2,000 minus 3,000 is -1,000, and then 60 minus 20 would be 40. If I divide that out, I'm going to get -25. Now notice this problem is in thousands of feet, cubic feet actually. So when I get -25, that really means -25,000. My y-axis on this problem represents the amount of water. The x-axis in this one represents the time. So slope for this problem, whoops, lost my pen, hang on a second. Sorry about that. The slope for this particular problem represents, is -25, so that represents the amount of water that the reservoir is losing per hour. So it looks like that it's going at a rate of, it's going down 25 feet per hour. All right, so now we've got a finding the slope from an equation. There's two different ways you can do this problem. I'm gonna show you using the slope formula, but I need two ordered pairs. The only method I know of that we've learned so far to get ordered pairs is doing intercepts. So this is a great little practice with intercepts. If I plug in a 0 there for x, I have 3y equals 12, which y will be 4. So my y-intercept is 0, 4. If I do the same process and I plug in a 0 instead for y, I get 2x equals 12, which will give me x equals 6. So my x-intercept is 6, 0. Now that I have two ordered pairs, I can plug it into the slope formula. y2 minus y1 over x2 minus x1 would give me 0 minus 4 over 6 minus 0. Negative 4 over 6 reduces to negative 2/3, which would be my slope for this problem. Don't forget mini table. Lots of students are more comfortable with mini table. If I do it this way, it's going up 4, it's going down 6. You still get 4 over negative 6, which still reduces to negative 2/3. Guys, it's the same process. It's just you just have to decide which one's more comfortable for you. Same exact thing on these two problems, so I'm not going to work through them all the way, but I will show you at least how to fix the equations. If I take 5x equals 90 minus 9y, it's really nice if I have this in standard form. Remember, standard form looks like this. ax plus by equals c, with the x value first, then the y value, and then equals, and then your number that's by itself. So if I had this little 9y over there by the x, it sure would make it better in finding the intercepts and then eventually finding the slope. So I'm going to take that 9y and I'm going to add it. I'm just going to make this equation become in standard form. So I've got 5x plus 9y equals 90. I would do the intercepts method, plugging in a 0 here, plugging in a 0 there. Well, I said I wasn't going to do it. I'll do it real quick. I'm hoping my timer won't run out on me. So if I put in the 0 for x right here, 9y equals 90, therefore y equals 10. That would be my y-intercept. If I put in the 0 here, I get 5x equals 90, therefore x equals, what would that be, 18. So my x-intercept is 18, 0. If you plug those into the slope formula, 0 minus 10 over 18 minus 0, you get, negative 10 over 18, which reduces to negative 5 over 9. That's your slope for this one. To find the slope for the last one, again, you'd want to fix it first. Let's get this thing in standard form. So you'll have 13x plus 5y equals 130. You can plug in the zeros and find the slope that way. And that is your slope formula notes.